So we're going to begin our discussion by just going through the explanation of an ordinary annuity. So a reminder about the ordinary annuity was you began at T0, right? And at T0, you got your loan. I'm going to use a loan as my example. So you got some money coming to you. It's a positive value. Then the very next time period, so at T1, you make a payment to start paying off the loan, PMT. And that's, negative value. And you continue doing this for every other time step to come. So T2, T3, all the way to Tn-1 and Tn. Okay, so there you pay off the loan. So let's just go ahead and write in those payments quick so you can see the visualization. So the payments happen all the way through. Okay, so that's your ordinary annuity. Your payments start occurring one time period after you get your loan. Now we're going to talk about a deferred annuity because in a lot of real world situations, you don't start paying off your loan directly after you get the loan, like one time period after. Sometimes your payments are deferred by a set period of time. So what's actually happening is you getting your loan at T0 kind of a thing. And once again, we're just going to use the loan as an example. So we're getting some money. Then what's going to happen is at T1, for example, say you don't pay, T2 you don't pay, etc. until some time period, and we're just going to call it TK. You start making your payments. So you start making your payments over there. And now what's going to happen is here you have your TK plus 1, and it's going to continue on, and it's going to continue on to Tn and Tn minus 1. So here you're going to see your payments are going to occur at all of these points. You're still going to end up with your future values equal to 0. So the only thing that's happened is for a set period of time, you don't make any payments towards the loan. That's what we mean by it's deferred. Your payments are being deferred for a set period of time. Now, what you can sort of see is there's actually two calculations occurring, because if you're not making any payments, then this is just essentially a compound interest situation. And we've done that before, like when you had your simple loans and you had no payments being made, it's just that. Then you're going to have your second part, which is your annuity, where you are making the payments. Now, where you split up into part 1 and part 2, you're going to have to mimic how an annuity works. So when you're mimicking how an annuity works, your annuity begins 1 month before you start making those payments. So I need to actually color in this here as part of my annuity. So now you see the way I made that part purple. Now you can see, oh, look, I have my annuity sits like that. It's everything in purple sitting there. So let's just highlight it. It's everything from here onwards. So that's part 2, which is my actual annuity occurring. And the yellow circle is part 1, the compound interest. And it's just normal compound interest occurring. So what is actually happening here is we have part 1, which is just your standard compound interest. And if we can find the future value of part 1 at the time that part 2 starts, we can then use that future value as our present value for our part 2 to work out a normal annuity structure. So we have a part 1 calculation and a part 2 calculation, which is something we have technically covered before. So The idea is if you have a deferred annuity, you have to remember how does your annuity work. If it's an ordinary annuity, then you need the present value one time step before you start making your payments. So that's why we colored in the one time step over here, because we started making our payments over here. So one time step before, that's the present value we need to match how ordinary annuities work. So that diagram up there. Then we look at the process and go, okay, well, how do we get that present value for that part of the calculation? And we go, well, we can use the first part of the calculation, which is just your standard compound interest kind of a formula and question. And we can use that future value as our present value for our part 2. And that's how deferred annuities are going to work when you do the calculations. So let's go ahead and jump straight into some examples, because I recognize that not everyone is going to see it straight away in this diagram. So here we have an example of a student secures a loan of $95,000 to pay for their studies on the 1st of February 2023. The loan is secured at 11.5% per annum compounded monthly. The student will start making monthly payments over 5 years starting on the 1st of February 2024. Calculate the value of the payments. So the first thing we're going to do is we're just going to draw a timeline. And now when we have payments, we will have the time periods of our timeline corresponding with the time periods of our payments. So when we do our timeline here, because our payments are monthly, our TN, our N year, is going to represent months. So our timeline's time periods are going to be connected to our payment periods. So we're going to have T0 sitting over there because that's when everything starts. And then we're going to have T1, and T1 has no payments being made because if you look at the question, it says you get the loan on the 1st of February 2023. You start making payments on the 1st of February 2024. So we're going to continue till T12, and that's when we start making payments. So here we have the present value is equal to $95,000. But nothing is being paid in until T12. Then from T12 onwards, every month, there is a payment. So we're just going to put the ellipsis starts there to show that it's going to continue. It's going to continue until TN. But I'm just going to also do one time period before that to show you that there's payments being made there and payments being made there, and then the future value is equal to 0. So once again, your timeline corresponds with the time periods used in your payments. We have the payment starting at T12 because they said that it starts making payments starting on the 1st of February 2024. So we started on the 1st of February 2023, so that was our T0. So T12 is going to be when we start making our payments. Now we have our payments in there, and then our future value is equal to 0. And it says here over 5 years. So for the payments, 5 years takes place. So that's 60 months. So we know if we go from here all the way to there, that's going to be 60 months. And I'm leaving it in like a very pale color at the moment, just so you can see it, but it's not, attacking you with information right now. Because right now, I actually want to discuss how we're going to break this up into 2 parts. Because remember, we have an annuity equation, but we also just have a normal compound interest equation where the payments are 0. So for our annuity part of our equation, remember for our ordinary annuity, we need the present value from 1 month before the payments start being made, because in an ordinary annuity, you get the loan and the very next time period you start making payments. So we actually need T11's information for our annuity equation or information. So I'm just going to color in everything that's going to be connected with the ordinary annuity in that purple. So you can see that part is connected to your ordinary annuity, which means we need a present value over here for that part of the calculation. These payments are also obviously part of the annuity. I'm just not going to rewrite them over in purple. Then we need a present value, right? Which means we need a future value from the part one. So part one is going to be everything left over. So we're going to need to get the future value at this point for part one and use it as our present value for our part two. So we have two parts. We have the part one, and then we have our part two, which sits over here. So let's actually start writing down our information for part one and part two. So for part one, it's from T0 to T11. And so where did we get that from? That's T0. We need the future value at T11 to use for our annuity equation. So it goes to T11. So we have that. T0 to T11, which means our N in this case is 11 months. Now, the fact that we use our payments as our timeline N, the easiest way when we put it into our financial calculator is, again, to remember we need to connect our N and our PY as the same units. So we know our PY is going to be equal to 12 because it's monthly payments, even though we're not making monthly payments, so that we don't have to do any conversions on our side. We can just use exactly what's coming from the timetable. We're going to have our PY is equal to 12. In this case, the CY and PY correspond and are both 12, but they won't always correspond. Now, next up, we have our interest rate. So that's J. So let's just quickly have a look. It is secured at 11.5% per annum compounded monthly. So we're going to say, okay, that's 11.5% per annum compounded monthly. And that's going to give us our IY is equal to 11.5 and our CY is equal to 12. So we still have our N and our PY corresponding. The N we can read directly off our timeline because we set our time periods in our timeline to correspond with the payment periods. That's why our PY is equal to 12 there. Then we have our normal interest, and we still get our IY from there and our CY from there. Okay? What else do we have? Well, we have our present value is equal to 95,000, and we want to find our future value. So that's what we want to find. We don't have any payments. We can say that PMT is equal to 0, but we don't have to, because if we cleared our information correctly, our default information in our calculator has PMT as 0. Okay. Which means we can then go and write the recipe for this. But what I'm going to do now is I'm first going to write down all the information for part 2 as well. So those of you that are like bored or something can skip ahead. So let's write down information for part 2. So our information for part 2 is coming from the purple. So it's from T11 to the TN, the final. And in this case, it's technically 60 months that is going to be taking place from your payments. So our final N here is 60 months. So that N that we were talking about over there, that is actually 71. Okay. You don't have to stress about that though. You could have gotten it straight from the fact that it was the 60 months is taking place. You paying it back over, your 5 years. 5 years is 60 months, and going from there. But just in case you're like, I don't like that, you can actually look at this and go, okay, you have 11 here, and then from this one here, all the way is 60 months. So 11 plus 60 gives you the 71. And then you can read the 60 months from 71 minus 11. So I'm just over explaining that there. You don't have to overly stress. The information said 5 years, so it's 60 months. But if you want to read it straight from the timeline, in very pale writing, I do have it indicated that from here all the way to here, that's 60 months. So now we say 11 plus the 60 is going to give us that value over there, which is the 71. Okay, so unnecessary extra information, but let's move on. Now, the other information that we still have the nominal interest as 11.5% per annum compounded monthly. I'm rewriting it because later on you will, have situations where the interest changes and stuff. So let's just get you in the habit of it. So IY is 11.5. Our CY is equal to 12. Our PY is equal to 12 because it's monthly payments. We don't know what those payments are though yet. And our future value here is going to be, our present value over here is going to be the future value from this one here. So it's going to be wherever we stored it, which means we're going to recall it on this side. So let me just write it in words so that we just remember. Recall future value of part 1. Okay. Is there anything else we're missing? So we have N, we have IY, we have CY, we have PY, we have PV, and we want to find PMT. We know that the future value here is equal to 0 because we're paying it off. So we don't have to put that in. Okay, so let's go ahead and write the recipes for our financial calculators, and then we will do the recordings of the financial calculator. So go through typing it on our financial calculator. So the first thing we're going to do is going to have second function CA. Then we're going to put in our compounding periods. So that's second function PY, and that's 12, ENT. And remember, we're doing the pink one, we're doing part 1. So we're getting our information from here. Then we're pushing down, and our CY is equal to 12, so we shouldn't have to update. Then we have the ONC, and we finish stage 2. Then stage 3, we just shove down everything that we know. So that's 11N. So that's coming from there. 11.5 IY. So that's coming from there or there, depending on where you want to read it from. Then it's 95,000, and it's a loan, so it's an inflow of money. So that's 95,000 PV. And we're going to compute our future value. And it's going to come up as negative. So we store it, because remember, we want to store it for the next part. We just need to acknowledge that it is going to be a negative value. And now we're going to do part 2. So we've stored our value, and we're going to do part 2. If you want to know the exact values and everything, skip ahead to where we actually typing it in on our calculator. So for part 2, we're going to use just the purple information. So it's going to be second function CA. Once again, we do all the clearing. Then we're going to put in our compounding periods and our payment periods. And it's the same information as what we did for part 1. So because we keep our payments the same, our timeline with the payments the same, bits of this is going to repeat. So PY, 12 ENT, check our CY. It should be the same because CY is equal to 12 as well. And we clear our screen. Then we put in the information that we need. So that's 60N. That's 11.5 IY. And then that is, we need to recall our information now. So it's a present value, so it's an inflow of money to us. So we're going to say plus minus recall wherever we recalled it in the last part. So I put it in variable A, and then I'm going to say present value. Then I'm going to ask it to compute the PMT. That is M, by the way. And that is going to give me a value of minus 2320.41, which means our payments are going to be 2320.41. Just a quick heads up, what I got for the future value, and you will see this when we do it with a financial calculator, is minus 105,508.51. So that's just a quick reminder. We are going to now do this on our financial calculator. So the first thing we want to do is we're just going to say second function CA to make sure there's no artifacts left over from previous calculations. And then we're going to do part one. And part one is technically just a normal compound interest situation where we're just having the loan grow without any payments. And so the CY and the PY are going to correspond because it's the quickest way to input our CY. Because now that you've done some annuities, you actually know that when you're doing this, and by not putting in the payments, you're just saying the payments are zero. So it's not having an effect. Okay, so we're going to say second function PY. The compounding period is 12, so we're going to put that as 12 and enter. And therefore, our CY is now 12. Then we're going to clear our screen. And then we're going to put in the information that we have. So it's a loan of 95,000 Rand. So we have 95,123 PV, and it's positive because it's a loan, so it's an inflow of money to us. Then we have 11.5% per annum compounded monthly. That is already as a normal interest, so we just type it in. And then we are going to put the N. So in this situation, our N is going to be, while we start paying off the loan directly a year after, we have to work out how much we owe just 1 month before that so we can start working out our payments of the loan. So that is why we have the N is equal to 11. So instead of the full 12 months, we work out 1 month ahead so we can start processing our payments from month 12. So we're going to have 11 N. And then we're just going to compute the future value. And we get the future value as minus 105,508.51. And it's negative because it's the amount of money that we owe. So the thing we're going to do now is we're going to store this on our calculator. So we're just going to say STO, and I'm going to choose variable A. So it's stored in my variable A. So I can use it for part two. Now for part two, we're just going to clear our screen there. And it's now in annuities where there are payments involved. So we're going to do the same thing as we did previously, where we enter our payment periods and our compounding periods first. So you're first going to say second function CA, once again to clear the artifacts. So you're going to do this with every single part. Don't forget to do it for every single part. And then we're going to enter our payment periods. So in this example, it's monthly payments. So it's second function PY12 and enter. And the compounding is monthly. So the fact that it corresponds is great. We don't have to change anything. So we just clear our screen there by pushing the ONC button. And now we put in our information for part two. So our information for part two is we have an interest of 11.5% still. Okay. Our present value for part two is our future value from part one. And it is a loan, so it's money that we technically still have. So we're going to put it in as positive. So we saved it as negative. So we're going to say plus minus recall A is equal to the present value. Okay. So that it's positive because it is a loan and it's technically money that we have. We haven't paid it off yet. Then we are going to put in the duration of the loan. So it is 5 years worth, but it needs to correspond with the payment periods, which is monthly. So it's 5 times 12 N. And now we're going to compute our payments by saying compute PMT. And we get it as minus 232.0.41. So those are going to be our monthly payments for the duration of 5 years.